Proton. A proton is a subatomic particle that plays a fundamental role in the structure of matter. Here are some key details about protons. Elementary particle. Protons are considered elementary particles, which means they are not made up of smaller particles. They are one of the building blocks of matter, along with neutrons and electrons. Charge. Protons have a positive electric charge. The charge of a proton is exactly equal in magnitude but opposite in sign to that of an electron, which has a negative charge. The elementary charge of a proton is approximately plus 1.602 times 10 to the 19 coulombs. Mass. The mass of a proton is approximately 1.672619 times 10 to the 27 kilograms, which is roughly 1836 times the mass of an electron. Protons and neutrons, collectively known as nucleons, are much more massive than electrons and are found in the nucleus of an atom. Location. Protons are primarily found in the nucleus of an atom, which is the central, densely packed region. Neutrons, which have no charge, also reside in the nucleus. Electrons, with their negative charge, orbit the nucleus in electron clouds. Atomic number. The number of protons in the nucleus of an atom is called the atomic number. It is a fundamental property that determines the identity of an element. For example, all carbon atoms have 6 protons in their nucleus, giving carbon an atomic number of 6. Stability. Protons are considered stable particles, meaning they do not spontaneously decay into other particles under normal conditions. However, in certain high-energy environments, such as in particle accelerators or during certain nuclear reactions, protons can transform into other particles. Strong nuclear force. Protons are held together in the nucleus by the strong nuclear force, one of the fundamental forces of nature. This force overcomes the electromagnetic repulsion between positively charged protons and helps bind them together with neutrons. Quarks. Protons are composite particles, made up of smaller particles called quarks. Each proton is composed of 3 quarks, 2 up quarks and 1 down quark. Quarks are elementary particles that come in 6 different types, or flavors, and they are never observed in isolation but always in combinations with hadrons like protons. Antiparticles. Protons have corresponding antiparticles called antiprotons, which have the same mass but opposite charge, negative. When a proton and an antiproton come into contact, they can annihilate each other, releasing a significant amount of energy. Role in chemistry. Protons play a crucial role in chemistry as they determine the chemical properties and reactivity of elements. The number of protons in an atom's nucleus determines its position on the periodic table and how it interacts with other atoms in chemical reactions. In summary, protons are essential particles in the realm of particle physics and the foundation of the structure of atoms. They are positively charged, relatively massive, and are found in the nucleus of atoms, where they contribute to an element's identity and stability.